Welcome to another episode of Euricalia. In this exciting journey, we will explore the planets, neighbors, visitors, and more unique facts about our magnificent galaxy. The Milky Way is a barred spiral galaxy, which means it has a central bar-shaped structure with spiral arms extending outward. It spans an impressive 100,000 light-years in diameter and contains an estimated 200 to 400 billion stars, making it one of the most massive galaxies in the observable universe. The Milky Way has fascinated astronomers for centuries, but its detailed structure and characteristics have been challenging to observe from within. Thanks to advancements in astronomy and space exploration, we have gained invaluable insights into our galaxy's many mysteries. The Milky Way's structure is composed of several key components. At the center, there's a dense, bulging region called the central bulge. This area contains older stars and likely harbors a supermassive black hole, known as Sagittarius A, with a mass of about 4 million times that of our Sun. The black hole's immense gravity influences the orbits of nearby stars. Surrounding the central bulge is the disk, a vast, flat region containing the majority of the Milky Way's stars, gas, and dust. This is where new stars form, as molecular clouds collapse under their own gravity. These young stars often cluster together in open star clusters. The disk also features beautiful spiral arms that wrap around the galaxy. These spiral arms are regions of ongoing star formation and host numerous bright and massive stars. While our solar system hosts 8 planets, the Milky Way galaxy likely contains hundreds of billions of planets. These exoplanets, or planets that orbit stars other than our Sun, come in various sizes, compositions, and orbital configurations. Astronomers employ various methods to detect exoplanets, including the transit method, which involves observing the slight dimming of a star's light when a planet passes in front of it, and the radial velocity method, which measures the star's wobble caused by the gravitational pull of orbiting planets. The search for exoplanets has led to remarkable discoveries, such as potentially habitable planets located in their star's habitable zone, where conditions may be suitable for liquid water, a crucial ingredient for life as we know it. The Milky Way is not an isolated island in space. It is part of a galactic neighborhood known as the Local Group. This group consists of over 50 galaxies, including our closest neighbor, the Andromeda Galaxy, M31, located about 2.5 million light-years away. In approximately 4.5 billion years, the Milky Way and Andromeda will engage in a celestial dance, destined for a dramatic collision. Although individual stars are unlikely to collide directly, the gravitational interaction will dramatically reshape both galaxies, eventually leading to their merger into a new, larger elliptical galaxy, sometimes humorously dubbed Milkomeda. The Milky Way occasionally welcomes cosmic visitors from distant galaxies. One such visitor was Oumuamua, an interstellar object that passed through our solar system in 2017. Oumuamua's name comes from the Hawaiian word for scout, reflecting its nature as the first confirmed interstellar object to be observed passing through our cosmic neighborhood. This elongated and mysterious object presented astronomers with a unique opportunity to study the properties of objects originating from distant star systems. Oumuamua's odd trajectory and acceleration puzzled scientists, leading to intriguing discussions about its possible origin and composition. This cosmic behemoth exerts a powerful gravitational pull on surrounding stars and gas. Sagittarius A doesn't actively consume nearby stars or planets, but as matter falls toward it, it forms an accretion disk. This disk of gas spiraling around the black hole emits intense radiation and powers the region known as the galactic center, a vibrant and dynamic part of our galaxy. The Milky Way is a hotbed of star formation, and its stellar nurseries are fascinating regions where new stars are born. Nebulas, vast clouds of gas and dust, are the cradles of these nascent stars. One of the most remarkable examples is the Orion Nebula, a stellar nursery located in the Orion constellation. Within the Orion Nebula, bright, young stars illuminate their surroundings, sculpting the nebula's intricate structures and playing a crucial role in enriching the surrounding interstellar medium with elements forged inside their cores. As we explore the Milky Way, we discover that certain regions are more favorable for the emergence and development of life. These regions, known as the galactic habitable zone, are areas where conditions are conducive to the formation and evolution of habitable planets. The galactic habitable zone depends on various factors, including the abundance of heavy elements like carbon, oxygen, and iron, as well as the level of radiation from nearby stars and supernovae. Studying the galactic habitable zone helps us understand the potential distribution of life within our galaxy. As we examine the history of the Milky Way, we discover evidence of its past cosmic feasts. The galaxy has engaged in countless interactions and mergers with smaller satellite galaxies over billions of years, a process known as galactic cannibalism. One remarkable example is the Sagittarius dwarf elliptical galaxy, a satellite galaxy currently being devoured by the Milky Way. This ongoing feast leaves behind streams of stars and stellar debris, tracing the telltale signs of past cosmic encounters. The Milky Way has a rich and storied history. As we examine the ages of stars within the galaxy, we gain insight into its formation and evolution. Some stars, known as population 2 stars, are among the oldest in the Milky Way, dating back to the early universe. In contrast, younger stars, like our Sun, belong to population 1 and formed later from enriched gas. Studying stellar ages and compositions allows astronomers to piece together the galaxy's evolutionary timeline and better understand its formation and growth over billions of years. Not all components of the Milky Way are visible to us. Scientists have uncovered evidence of a mysterious substance called dark matter, which outweighs regular matter by a significant margin. Dark matter forms an extensive halo surrounding the galaxy and contributes to its gravitational pull, helping to maintain the stability of the Milky Way's structure. Despite its invisibility, the presence of dark matter has profound implications for the galaxy's formation and behavior, shaping the way stars and galaxies interact on cosmic scales. The Milky Way possesses a magnetic field that permeates the entire galaxy. This galactic magnetic field plays a crucial role in shaping the behavior of cosmic rays and charged particles as they traverse the galaxy. It also influences star formation, galactic winds, and even the motion of celestial bodies within the Milky Way. As we peer into the distant future, we envision the fate of our beloved Milky Way galaxy. In about 5 billion years, the Sun will exhaust its nuclear fuel and expand into a red giant, eventually shedding its outer layers to become a white dwarf. The expanding Sun will alter the dynamics of the solar system, and the Earth, as we know it, will face a very different fate. Meanwhile, the galaxy will continue to evolve, interact with other galaxies, and undergo cosmic transformations on timescales that dwarf human lifetimes. The ongoing study of the Milky Way allows us to glimpse the deep-time evolution of a galactic system and appreciate the dynamic nature of our universe. As inhabitants of the Milky Way, we find ourselves in a unique position to explore and understand the vastness of the cosmos. Our curiosity and passion for discovery have led us to venture into space, revealing the wonders of our galaxy and the universe beyond. Studying the Milky Way allows us to reflect on our place in the cosmos. We are not separate from the universe but are an integral part of it, connected to every star, planet, and cosmic event. This knowledge fuels our drive to explore and pushes the boundaries of human understanding. Thanks for joining us on today's episode of Euricalia. Stay curious, keep experimenting, and may your adventures be filled with discoveries.